Hello students, today we are going to continue with our concept operations on sets. In our previous class we had a discussion about what are the operations we have, how many types we have, and a brief introduction was given. Today let us go for still more. We can extend our concept operations on sets with some example programs. Now the first operation, as we know that the first operation is union of sets. Union of sets. The definition for union of sets, the set builder form, is nothing but let A and B are any two non-empty sets, then the union of sets is A union B is equal to X such that X belongs to A or X belongs to B. So this is the definition about union of sets. Union of sets, as we know that when we have two non-empty sets A and B, union means combining all the elements of presenting in set A and presenting in set B. So whatever the elements we have in set A, whatever the elements we have in set B, both elements we have to combine. That is nothing but called union of sets. The set builder form, the general definition of sets union of set is nothing but A union B is equal to X such that. So means in A union B we have an element of X. How we are getting this X? So this X may be in set A or may be in set B. So whether the X, it may be in A or it may be in B. In any one set, if the element is there, that element automatically comes into A union B. That element automatically comes into A union B. So X may be in set A or X may be in set B. There is no compulsory that it has to be in both the sets. Only one set is enough. If it is a one set, then automatically it comes under union. So here A union B is also nothing but a set. So combining all the elements, we are forming a new set. That new set is nothing but called A union B. When we calculate A union B or B union A, A union B or B union A, both gives the same result. Both gives us same result. Even when we consider B union A, here also X may be in set B, X may be in set A. So B union A union B, both gives us same result. A union B union A, both gives us same result. Like in addition, 2 plus 3 is equal to 5. 3 plus 2 is equal to 5. Means 2 plus 3 is equal to 3 plus 2, which is nothing but called commutative property. So here also union of sets satisfies the commutative property. We have plenty properties based on union of sets and intersection of sets that we discuss later. First, let us know the definition of union of sets. Let A and B are any two non-empty sets, then the union of sets is This is the symbol for union, as we know that. So A union B is equal to X such that X belongs to A or X belongs to B. This is about union. Now coming for the intersection of sets. Intersection of sets. What is the meaning of intersection of sets? We know that. So when we have intersection operation, let A and B are any two non-empty sets, then the intersection of sets is intersection A intersection. This is the symbol for intersection. A intersection. What is the meaning of intersection? Intersection means we are going to collect the common elements which are presenting in both the sets. Set A we have some elements, set B we have some elements. In these two sets we may have common elements. So collecting those common elements are nothing but called intersection of sets. So A intersection B, the definition is X such that X belongs to A and X belongs to B. And means it has to be in both. Union means or intersection means and. Union either A or B. But and means A and B means the element has to be in both. So A intersection B, how we are getting the element means, in A intersection B we have an element X. How you are getting this element X means, X must be in A, X must be in B. So X has to be in both the sets. X has to be in both set A and set B. Then only it comes under intersection. This is about A intersection. So just nothing but collecting the common element. Now you may ask that, sir, if there is no common elements, if there is no common element means our answer is empty set. If there is no common element, then what you will write? Just empty set. The answer is what? 5. There is no 100% guarantee of that we have common elements in both the sets. Sometimes you may have common elements, sometimes you may not have common elements. There is no rule of that we should have common elements. That is depending on the situation. Sometimes we get common elements, sometimes we may not get common elements. So whenever there is no common elements, our answer is an empty set. Whenever there is a common element, just we will collect the common elements and we form a new set which is nothing but called intersection. So like union, A intersection B and B intersection A is also same. Here also X must be in B as well as X must be in A. Like multiplication. In numbers we have multiplication. 2 3s are 6, 3 2s are 6. Means 2 into 3 is equal to 3 into 2. Like the product, how it is satisfying the commutative property, here also the intersection is satisfying commutative property. So what we can say here, A intersection B and B intersection A both are equal, which satisfies the commutative property. So this is about the definition of intersection. This is about definition of intersection. Now we have the third operation. What is the third operation? We have difference of sets. What we have? Difference of sets. Now what is the meaning of difference of sets and how we are going to do here? So difference means subtraction, A minus B. So the definition of A minus B, in our previous class with one example I have explained to you. how to find the difference. How to find the difference means we need to identify common elements from both set A and set B. We have to eliminate the common elements. After eliminating the common elements, the elements which are left in the first set. Here what is the first set? A. So after eliminating the common elements which are left in set A, that is nothing but A minus B. Means that here A minus B, if you have an element, that element has to be only in A, not in B. Means that X belongs to A and X does not belongs to B. So A minus B is a set. This set is having an element X. How this element is getting? This element is in A but not in B. The element X where it be? It has to be only in set A, means the first set. Here what is the first set we are taking? A. So element X also has to be in first set but not in the second set. That is A minus B. Now let us come for B minus C. Like A minus B. What is the B minus C? Now what is the first set? B. So the element has to be in set B but not in set A. So X belongs to B and X does not belongs to A. This is about difference of the sets A minus B and B minus A. Now A union B satisfying commutative property. Intersection is also satisfying commutative property. Now what about the difference? Let us see here. 3 minus 2 is 1. 2 minus 3 is minus 1. Means 3 minus 2 is not equal to 2 minus 3. Which is not satisfying commutative property. Which is not satisfying the commutative property. When it is not satisfying the commutative property, even in sets also the same. Means here A minus B is not equal to B minus A. So the difference of sets is not satisfying the commutative property. So union of sets, intersection of sets are satisfying commutative property, whereas difference of sets is not satisfying the commutative property. These are about the definitions of union, intersection and difference of sets. Now we see the Venn diagrams of union, intersection and difference. Venn diagrams. So A union B, the first Venn diagram we have, and A intersection B, the third one, second one we have, A minus B and B minus A. So total we have 3 Venn diagrams. A union B. As we know that every set is a subset for universal set. Without universe, we are not there. When there is a universe, we are the part of universe. Similarly, when we have A and B, means A and B are part of universal set. So, first we need to consider universal set. As we know that universal set is always represents with rectangular box and the symbol for union is U, capital U. This is the symbol for universal set. Now, in this universal set, we have 2 sets. One is set A, another one is set B. A, B. So, what we want here? Union. Union in the sense, we need to combine all the elements of set A, all the elements of set B. Now, let us mark the set A with horizontal line to understand set B with the horizontal line, vertical lines. So the horizontal lines representing for us set A. Horizontal lines representing for us set A. Now the vertical lines are representing for us set B. Vertical lines are representing for us set B. This is about shading of set A, shading of set B. Now what my concept union means, here the set A and set B, all elements together I want to take. Means these are the set A elements and these are the set B elements. All together we need to combine. We need to combine both. Means A union means this entire portion is nothing but for us A union B. So this total shaded portion gives us A union B. Means A union B is equal to horizontal lines. Means wherever the horizontal lines are there, that entire portion, plus vertical line, wherever the vertical lines are there, that entire portion. Means indirectly this total area is nothing but Venn diagram for A union B. Now coming for A intersection B. A intersection B also we have the same. When we have a rectangular line, rectangular box which indicates union of sets, and in this universal again we have two subsets. One is set A, another one is set B. This is about set A, this is about set B. Now you observe here intersection. What I told you, intersection, common elements, means we need to collect only the common part. Now when you observe this diagram, what we have the common part? This is the portion which belongs to in both the set A and both set B. This is the place we want. Let us take set A when we consider as horizontal line. Set A entirely we are shading with the horizontal lines. These are the horizontal lines we have. Now set B, we are going to have only the vertical lines. Set B we are representing with vertical lines. So horizontal lines and vertical lines we have. Now intersection, as I told you, intersection means where the horizontal and vertical lines together we have. Horizontal lines and vertical lines together we have. So wherever horizontal and vertical lines together we have, there we have the boxes. There we have the boxes. Where the boxes are there? So this is the area we have the boxes, means just like filters we have. So this portion is nothing but called A intersection B. So A intersection B is nothing but where we have both horizontal and vertical lines we have. This portion, like these boxes, wherever we have, that area is nothing but A intersection B. So this entire portion is A union B. Only the common part where we have the boxes, means where we have both horizontal and vertical lines together, that area is nothing but called A intersection B. Now let us come for A union B. So A minus B. So this is universal set, and in this universal set we have two subsets, set A and set B. This is about set A and this is about set B. As I told you, A minus B. A minus B means what? The element has to be in A but not in B. When we have an element in A minus B, which gives us element must be in set A but not in set B. Not in set B means now you observe the shaded portion is only for A, means in this shaded portion I am not including B, means completely the part of B we are eliminating. Only means you may ask, sir, this is also part of A now? Yes, it is also part of A, but this part is also part of B. This is common part for both A and B. When we are eliminating B, so we should not consider this also. So this is nothing but A minus B. This part, this shaded portion is nothing but called what? A minus B, means only A but not B. Now B minus A. B minus A. So, when we observe this vertical line portion, we are considering only the part B. We are excluding completely part A. So, this portion is nothing but called B minus A. So, A minus B nothing but where we have only horizontal lines. B minus A is nothing but where we have only vertical lines. Now what about this common part? This is nothing but A intersection B, means from both set A and set B we are eliminating intersection part. What we are eliminating? Intersection part. So from the entire set A, if you eliminate intersection part, what we are getting? A minus B. From the set B, when we eliminate intersection part, what we are getting? B minus A, means the formula for A minus B from the Venn diagram I can say that A minus A intersection B. Similarly, B minus A is nothing but B minus A intersection B. So these are the two more formulae we can define for A minus B as well as B minus A. See, simple logic. This entire is A. From this, when we eliminate the intersection part, we are getting A minus B. This entire is B. From this, if you eliminate that intersection part, the portion you are getting B minus A. Which part we are eliminating? Intersection part. Eliminating in the sense difference. So, from set A, when we subtract intersection part, we are getting A minus B. From set B, we eliminate intersection part, we are getting B minus A. So, these are the Venn diagrams for A union B, A intersection B, A minus B, B minus A. So, this is about a brief information on operations on sets. Now we see the different model problems, how to solve all these union, intersection and difference of sets. Now the next concept is complement of a set. Complement of a set. So what is the meaning of complement of a set? For example, let A is a set, U is a universal set. Now, from the universal set, when we eliminate set A, for example, our school is universal set. Our school is what? Universal set. Now, our classroom is a part of a school. Our classroom, our class 11 is part of a school. Now, if from the entire school, class 11 we have kept aside, means we have eliminated class 11. When we have eliminated class 11, the remaining entire school is nothing but called complement. Means that class 11 is set A. Other than class 11 is nothing but called complement. Is nothing but called what? Complement. Means just from the universal set, we are eliminating set A. From the entire school, we are eliminating class 11. When we eliminate class 11, the remaining total is nothing but called complement. So, when there is set A, when there is universal set, from the universal set, when we eliminate set A, from the universal set, we eliminate set A. From the universal set, we eliminate set A, which is nothing but called complement. We can write it as A dash, or we can write it as A power C. So A power C means A complement, or A dash is nothing but universal set minus set A. Universal set minus A. So from the entire universal set, we are eliminating set A elements. Its set builder form is nothing but X such that X belongs to universal set U and X does not belong to set A. X such that X belongs to, where is the element X? It is in universal set, but it is not in set A. So this is nothing but called A complement or A dash. A complement or A dash. Now let us have the Venn diagram for A complement. Venn diagram. So how the Venn diagram will be? We have to take universal set. This is our universal set U. In this universal set, we have set A. This is our set A. Now, what I am telling in simple word, other than A is nothing but called universal set. Other than A means excluding this A. Excluding this A means the shaded portion. The entire shaded portion gives us a complement. The entire shaded portion gives us what? A complement. Now what we have done here? We have a universal set. From the entire universal set, we are eliminating set A. We are eliminating what? Set A. So by eliminating set A, whatever the portion we have, this portion is nothing but called what? Complement of set A. So A complement or A dash is nothing but universal set minus A, that is X such that X belongs to universal set and X does not belongs to A. This is about the Venn diagram for complement of a set.